Alright, so now we're going to continue on this and we're going to actually look at Wien's displacement law and explain the connection between color and the temperature of stars. This is very important. We're also going to look at the classification of stars. They have different classes and we will discuss that. So that should be fine for this section. So going on to here again, as I said before, with black body radiation, you can actually study this in the laboratory, and so a further experiment was actually done by heating up different objects. Scientists and experimental physicists and so forth found out a very important and very interesting phenomena. They found that when you heat up something, an object to a certain temperature, there is a characteristic curve, and it looks something like this, where this over here is the intensity of the light, and this over here is the wavelength. And they found that the wavelength that corresponds to where most of the energy is being emitted, we call it lambda max. That lambda max times by the temperature of the object equaled a constant. And that constant is actually 2.9 times 10 to the negative 3. Obviously, that is going to be, the lambda is in meters and the temperature is in Kelvin, so the unit of that. So this was really interesting, because we can actually do the same thing with stars. We can look at the energy that we're getting from stars, and by looking at the lambda max, by looking at this value over here, from that we can actually work out the temperature of the star. In actual fact, this lambda max, where most of the energy is actually coming, actually gives off a certain color corresponding to that wavelength, and therefore, for instance, our sun, most of the energy is being given off as in the visible spectrum in the yellow, and that's why it looks yellow. So this is a very important fact that we use, and as I said, it was discovered in the laboratory and can be applied. So going back now to our discussion, we've looked at this over here, and we've seen about the color and temperature of stars. Now, what it has been seen is that stars have got different colors which relate to different temperatures. So here we have got a bluish star that would be a very high temperature. So they would look at the star and they would measure and see where is most of the energy coming from, and it would actually look that color. Our sun is in this region over here, and it's about that temperature. So astronomers have decided to label these according to letters. So we get O, B, A, F, G, K, M, and then L, T. We don't really use those all that much. Up to here is ones that we use quite a lot. And so according to their color, they actually have labeled different stars. We have got some easy way of remembering these, as you would have seen. If I go here, oh, be a fine girl, guy, kiss me, and some that are not all that culturally sensitive. So you can use these, but it is important you need to know this table. You need to know the classes, what they stand for, the different temperature ranges that we would actually have, and the related colors. Fine, so I think I'm going to leave this video here, and then I'll continue next time. Thank you.